Now, we are concluding this chapter with few more set of problems on straight line. So, 141, problem number 141 is A0, B0B and C00, that means C is the origin, are the vertices of a triangle. If the medians AD and BE are at right angles, then 2A is equal to B, 2, A is equal to 2B, C, 3, A is equal to B, and 4, none. Now, by hypothesis, the midpoint D of BC is 0, B by 2, and midpoint E of AC is A by 2, 0, are the midpoints of BC and AC. So, slope of AD into slope of BE is equal to -1 because they are given to be at right angles, implies that is if and only if B minus 0, A 0 minus B by 2 by A minus 0 and B minus 0 by 0 minus A by 2 is equal to -1. So, that is if and only if minus B by 2A into minus 2B by A is equal to -1, or that is A square plus B square is equal to 0, which is impossible. Okay. So, that means there is no such triangle. These three vertices, these 3 points cannot be vertices of a triangle such that the medians are at right angles to each other. So, therefore, the correct option is none, which is 4, 142. The point of intersection of the lines x by a plus y by b is equal to 1 and x by b plus y by a is equal to 1 lies on the line x plus y equal to 0, x minus y is equal to 0, 2x plus y equal to 0 and 2x minus y is equal to 0. So, if you solve that equations, if you subtract one from the other, x into 1 by a minus 1 by b plus y into 1 by b minus 1 by a is equal to 0, or that is x minus y is equal to 0. Hence, the point of intersection lies on the line x minus y is equal to 0, which is nothing but y is equal to x. So, the point of intersection of the lines x by a plus y by b is equal to 1 and x by b plus y by a is equal to 1 lies on the line y is equal to x. So, the correct option is option number 2, 143. The diagonals AC and BD of a rhombus intersect. The diagonals AC and BD of a rhombus intersects in 5, 6. If A is 3 by 3, 2, then the equation of the diagonal BD is y minus x is equal to 1, 2, 2y minus x is equal to 17, 3, y minus 2x plus 4 equal to 0 and 4, 2y plus x is equal to 17. Now, you know that m 5, 6 is the intersection of the diagonals AC and BD, AC and BD itself. The slope of the diagonal AC is 6 minus 2 by 5 minus 3, which is 2. And the equation of the diagonal BD is y minus 6 is equal to minus half into x minus 5, because the BD and AC, they intersect at right angles. They are at right angles to each other. So, therefore, its slope must be minus 1 by 2, because the slope of AC is 2. So, its equation is y minus 6 is equal to minus 1 by 2 into x minus 5, which is x plus 2 x plus 2y is equal to 17. So, correct option is option 4. Option 4, 144. If 3a minus 2b plus 5c equal to 0, then the equation ax plus by plus c equal to 0 represents a family of concurrent lines, concurrent at the point 3, 5, 3 by 5, 2 by 5, 2 minus 3 by 5, 2 by 5, 3, 3 by 5, minus 2 by 5, 4 minus 3 by 5, minus 2 by 5. Right. 3a minus 2, for all these problems, very simple. The technique is, because these type of problems are important, especially for EAPCET. So, whatever the coefficient of C you will be having in the given condition, you divide that the equation by the coefficient of C. Here 3a minus 2b plus 5c equal to 0. So, 5. So, divide that by 5. then you will get A into 3 by 5 plus B into minus 2 by 5 plus C equal to 0. That means the line AX plus BY plus C passes through what 3 by 5 comma minus 2 by 5. So that is correct option is minus 3 by 5 comma 2 by 5, which is 2. Sorry, 3 by 5 comma minus 2 by 5. The correct option is answer option number 3. So because please remember that is if the coefficients A, B, C of a straight line satisfies a condition, namely what you will get is AL plus BM plus CN equal to 0, where n is not equal to 0. Then the line AX plus BY plus C equal to 0, L by N comma passes through L by N comma M by N, provided n is not equal to 0. Okay, that is the general principle. Whatever relation that A, B, C satisfy with some numbers L, M and N, then you divide the coefficient of C throughout and take that line is L by N and M by N is the fixed point through which the line AX plus BY plus C equal to 0 passing. The area of the triangle formed by the lines y is equal to mod x and the line x plus 2y plus 2 equal to 0 is 8 by 3, 2 4 by 3, 3 4 and 16 by 3. Of course, the units are square units, even though I didn't write, but area means square units. And y is equal to mod x means, you know that y is equal to plus or minus x. That means the lines are given to be y is equal to x and y is equal to minus x. So, put y is equal to x in the given line, so that the line x plus 2y is equal to 2 meets the line y is equal to x, y is equal to x in the point 2 by 3 comma 2 by 3 P, and they put y is equal to minus x in the given equation, then you will get the point Q as minus 2 comma 2. So, area of triangle POQ, area of the triangle POQ is half of 2 by 3 into 2 minus 2 by 3 into minus 2, so which is nothing but 4 by 3 square units. So, correct option is 4 by 3, and you know that if x1, y1, x2, y2 and origin are the 3 vertices of a triangle, or one origin is one vertex and other 2 vertices are x1, y1, x2, y2, then the area of the triangle is half of mod x1, y2 minus x2, y1. Now, 146. ABCD is a square where A is equal to 1, 2 and B is equal to 3 minus 4. If the line CD passes through the point 3 comma 8, then the midpoint of CD is 1, 2 comma 6, 2, 6 comma 2, 3, 2 comma 5 and 4, 25 by 5 comma 1 by 5. Not 25, it is 28 by 5, 28 by 5 comma 1 by 5. Now, see the diagram. That line CD is parallel to AB and it passes to 3 comma 8. The slope of the line AB is minus 4 minus 2 by 3 minus 1, which is you will get minus 3. The slope of AB is minus 3. So, the slope of CD must be also minus 3 because CD is parallel to AB. So, therefore, equation of the side CD is equal to is y minus 8 is equal to minus 3 into x minus 3, which is 3x plus y is equal to 17. What is asked? The CD passes through 3 comma 8, then the midpoint of CD asked. For the square, because it is a square, if you draw the perpendicular to AB at the midpoint of AB, then that line must intersect the side CD in its own midpoint. Okay? Because ABCD is a square, if M is the midpoint of AB, M is the midpoint of AB, then the line passing through the midpoint of AB and at right angles to AB meets the side CD in its midpoint. So, you can write midpoint of AB is equal to 2 comma minus 1. The line through M and perpendicular to AB meets the CD in the midpoint N. So, therefore, equation of the line and equation of the line Mn is y plus 1 is equal to 1 by 3 into x minus 2 because Mn is perpendicular to AB and slope of AB is minus 3. So, slope of Mn is 1 by 3. So, which is x minus 3y is equal to 5. Now, solving this equation with CD equation, we will get the point n is equal to 28 by 5 and 1 by 5. So, correct option is 4, option number 4. So, here we have, see actually some people what they do is, they write the equation of AD, because the AD is passing through 1, 2 and perpendicular to the line AB. So, they calculate it and solve that AD equation with the CD equation. Then they will get the coordinates of D. And similarly, BC equation, because passing through B and perpendicular to CD. So, you can write the equation of BC and solve with CD. Then you get C. So, when you get C and D, then you can write the median midpoint. But here the thing is, because ABCD is a square, the midpoint of CD is nothing but the point of intersection of the line passing through the midpoint of AB and perpendicular to AB. Perpendicular to AB. It meets at some point in the side CD, and which is the midpoint of CD. So, the correct option is option number 4. Next, in triangle ABC, the equation of the perpendicular bisector of the sides AB and AC are x plus y equal to 0 and x minus y equal to 0 respectively. If the vertex A is 5, 7, then the equation of the side BC is, again, of course, the same model problem we did already, of course, by changing the hypothesis, not hypothesis, changing the equations. So, here the perpendicular bisectors of the sides AB and AC are nothing but the lines y is equal to x and y is equal to minus x. So, B is the reflection of A, 7 in the line y is equal to minus x. So, B can be minus 7, minus 5. Similarly, C is the image of A in the line y is equal to x, which is, so the C is equal to 7, 5. The coordinates will be altered. So, BC passing through origin. The BC, because please remember that is, BC is passing through origin. Why? How do you get that BC passing through origin? It is B is minus 7, minus 5 and C is 7, 5. So, the midpoint of BC is nothing but 0, 0. So, observe that is the fact. To identification of that fact is very easy. So, the side BC passes through 0, 0. So, therefore, the equation of the side BC is y is equal to 10 by 14 into x, but that is equal to 5x by 7. So, answer number, option number 1. Of course, here you must note that another side is 2x minus y plus 6 equal to 0. Because there will be, for 3, if you are given 3 line, then there will be one line to the side of 2x minus y minus 4 equal to 0 and another line the other side. So, actually you will get 2 lines, out of which one line is asked, can be, that's why square, can be is. Next problem. Next, 149. The diagonals of a parallelogram are along the lines x plus 3y is equal to 4 and 6x minus 2y is equal to 7. The parallelogram can be one rectangle or rhombus, and square or rhombus or square. Okay. Now, you can see that the slope of the diagonals are, the slope of one diagonal is minus 1 by 3 and the slope of the other diagonal is 3. That means slopes of the diagonals are at right angles. So, when the diagonals of a parallelogram are at right angles, then it can be a square or rhombus. Understand? In square also the diagonals are at right angles. In rhombus also the diagonals are at right angles. So, therefore, the correct option is option number 3, square or rhombus. But in generally many books they are given as rhombus. The answer is rhombus. Okay, of course, this is also asked in some JE or some paper, but there he has given rhombus. But when diagonals are at right angles, then it can be a rhombus or a square. The only thing is the difference between rhombus and square, diagonals are at right angles. In a square, these adjacent sides are at right angles. In a rhombus, adjacent sides are not at right angles. That is the only thing. Okay, correct option is 3. Next, 150. If two sides of a triangle are represented by 2x minus 3y plus 4 equal to 0 and 3x plus 2y minus 3 equal to 0, then its orthocenter lies on the line x minus y plus 8 by 14 equal to 0, 3x minus 2y plus 1 equal to 0, 9x minus y plus 9 by 13 equal to 0, and 4x plus 3y plus 5 by 13 equal to 0. Now, see the two lines. The slope of one line is 2 by 3 and the slope of other line is minus 3 by 2. So, these two lines are at right angles. That means the given triangle is a right angled triangle. The given triangle is a right angled triangle. For a right angled triangle, the orthocenter is nothing but the right angled vertex. Orthocenter is nothing but the right angled vertex. So, and the orthocenter vertex is nothing but 1 by 3 comma 1 by 13 comma 18 by 13, and it lies on the line 9x minus y plus 19 by 13 equal to 0. Please check 1 by 13 comma 18 by 13 satisfies 9x minus y plus 19 by 3 equal to 0 or not. So, the correct option is option number 3. Option number 3. Because for a right angle triangle, the orthocenter is in right angled vertex. For an equilateral triangle, the orthocenter, centroid, incenter, circumcenter, all are same for an equilateral triangle. Next, 151. Equation of the line equidistant from the lines 3x plus 4y minus 25 equal to 0 and 3x plus 4y plus 25 equal to 0 is 6x plus 4y plus 5 equal to 0, 3x plus 4y is equal to 0, 3x minus 4y equal to 0, and 6x plus 8y plus 5 equal to 0. Now, you can see that the two given lines are parallel lines. The given lines are parallel lines, and the distance between those two is 25 plus modulo 25 plus 25 by square root of 3 square plus 4 square. That means 50 by 5, which is 10. So, the distance between those two parallel lines is 10. Now, equation of the line equidistant from these two lines means it must lie in between the two given lines, and the distance between those two is half of the distance between the original lines from those two. So, that means the line midway between the two given lines and at a distance of 5 units from both the lines. So, distance between the given lines is 10, and it can be verified that the line 3x plus 4y equal to 0 is parallel to the given lines and is at a distance of 5 from each of the lines itself. That is 3x plus 4y. Here you can check, just verify. Here this is not, because the distance between them is 10, but the distance of 6x minus plus 4y plus 5 equal to 0 from one of the lines is nothing but 25 plus 5 by 5. So, that means 25 is 6 units, and third is not, that is again same, and fourth is not, and sixth is you can set number 2, 3x plus 4y equal to 0, whose distance from one of these lines is 25 minus 0 by square root of 3 square plus 4 square. So, 25 minus 0 by 5, that is 25 by 5 means 5. So, that is the line parallel to the two lines in between those two lines at a distance of 5 units. So, the correct option is 2, 152. If x1, x2, x3 as well as y1, y2, y3 are in AP, then the points A x1, y1, B x2, y2 and C x3, y3 are the vertices of an equilateral triangle, vertices of a right angle triangle, vertices of a right angled isosceles triangle, and fourth option is collinear. Now you know that because those coordinates are collinear, or in AP, x2 minus x1 is equal to x3 minus x2, and y2 minus y1 is equal to y3 minus y2. So y2 minus y1 by x2 minus x1 is equal to y3 minus y2 by x3 minus x2. So that means slope of AB is same as slope of BC. Slope of AB is same as slope of BC. That means ABC are collinear. ABC are collinear. So correct option is number 4. 153. The equation of the obtuse angle bisector of the angle between the lines x minus y plus 2 equal to 0 and x plus 2y minus 5 equal to 0 is so and so. Options are given. Now here a small technique. Of course, that is the technique to find which bisector is an acute angle, which bisector is an obtuse angle. There will be two methods. Of course, first method is simply, we have discussed that the pair of the angle bisectors between two lines a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0 are given by a1x plus b1y plus c1 by root over a1 square plus b1 square is equal to plus or minus a2x plus b2y plus c2 by root over a2 square plus b2 square. That is, and with one sign, with plus sign, you will get one bisector, and with minus sign, you will get another bisector, because angle between two lines means there will be two angles, theta and 180 minus theta. Among these two, one bisects theta, angle theta, and the other bisects angle 180 minus theta. And of course, remember that for any angle bisectors, if you take the angle bisectors of a angle between two lines, they will be always at right angles. Okay. So now here, how to identify the bisectors? That means which bisector with plus sign or minus sign bisects the acute angle or obtuse angle. For that, there is a procedure. In the given equations of the lines, make both constant terms positive or both negative, whatever may be. In fact, you make them both of C1, C2 as positive. That means C1, C2 are positive, well and good. If one of them is negative, that make multiply that equation with minus sign. Understand? Then you regard them as the equation again a1x plus b1y, a2x plus b2, like etc. Now you calculate a1, a2 plus b1, b2 after making the same sign for both C1, C2 are positive. Then if a1, a2 plus b1, b2 is negative, okay, then the bisector with plus sign will give you the acute angle. Positive, the bisector with the minus sign will give you the negative one. If you want, if it is discussed in intermediate, I think intermediate textbook it is discussed, I think. But what are books? The question bank for EAPCET written by Telugu Academy, published by Telugu Academy. In that it was given. So you go through that one. So here what I have written is, see, x minus y plus 2 equal to 0, and the other equation, because minus 5, so I want to make plus 5. Minus x minus 2y plus 5 equal to 0 by making C1, C2 positive. Now a1, a2 plus b1, b2 means 1 into minus 1 plus minus 1 into minus 2, which is 1 positive. So therefore, x minus y plus 2 by root 2 minus x plus 2y minus 5 by root 5 is the obtuse angle bisector. So which is nothing but the correct option is option number 3. That is. So if it is positive, plus sign is the acute angle, minus sign obtuse angle. 154. The equation of the line through 2, minus 4, which cuts the coordinate axis so that the intercepts are equal in magnitude but opposite in sign is 1 x plus y plus 2 equal to 0, x minus y plus 2 equal to 0, x plus y plus 6 equal to 0, and x minus y minus 6 equal to 0. Now, you know that intercepts are equal in magnitude, but opposite sign means a and minus a. The intercepts are a and minus a. So, here suppose the line x minus y is equal to a, which passes through 2 comma minus 4. It's not. So, this indicates a is equal to 6. So, therefore, required line is x minus y minus 6 equal to 0, which is option number 4. Option number 4 itself. Next, 155. If a straight line whose sum of the reciprocals of the intercepts on the axis is always constant equal to k not equal to 0, then the line passes through a fixed point 1 k comma k, minus k comma k, 1 by k comma 1 by k, and minus 1 by k comma minus 1 by k. And see, suppose the line is x by a plus y by b is equal to 1. So that the reciprocals are a and b, and by hypothesis the sum of the reciprocals, that is 1 by a plus 1 by b is equal to k, or 1 by ka plus 1 by kb is equal to 1. That means x by a plus y by b is equal to 1 passes through 1 by k comma 1 by k. So, which is correct option is option 3. For this, some people they did this problem in a clumsy way by finding the points of intersection, everything. But it's not necessary, because some of the reciprocals you are given. So, that means 1 by a plus 1 by b is equal to some constant k not equal to 0. So, divide by that k, so that you will get 1 by ka plus 1 by kb is equal to 1. So, the line passes through x by a is not, that line passes through 1 by k comma 1 by k. The sum of the slopes of the lines which pass through the intersection of the lines x plus y is equal to 0 and x minus y equal to 0, that is the origin, and whose distance from the point 2 comma 0 is 1 is sum of the slopes. So, 1 0, 2 1 by 3, 3 minus 1 by 3, 4 9. So, x plus y equal to 0 and x minus y equal to 0 intersect at origin 0 0. So, required lines are of the form, and you know that both lines they are intersecting at 0 0, and required line is of the form x plus y plus lambda into x minus y is equal to 0. So, the line is 1 plus lambda into x plus 1 minus lambda into y equal to 0. Now, the distance of this line from the point 2 comma 0 is 1 unit. So, that is 1 is equal to modulus of 1 plus lambda by 2, lambda into 2 by root over 1 plus lambda square plus 1 minus lambda whole square. Now, squaring and simplifying, you will get lambda is equal to minus 2 plus or minus root 3. Substituting the values of lambda in 1, the required lines are x plus y root 3 and x minus y root 3 equal to 0. Therefore, the sum of the slopes is, slope is for one line slope is minus 1 by 3 and the other is plus 1 by 3. So, the sum of the slopes is equal to 0, which is option number 1, 157. One of the slopes of the lines passing through the point A0 and whose perpendicular distance from the point 2a comma 2a is 1, 2 minus 1, 3, 3 by 4, 4 minus 4 by 3. So, suppose y is equal to m into x minus a be the line. So, any line passing through a comma 0, you can take it as y is equal to y minus 0 is equal to m into x minus a. Now, the distance of this line from 2a comma 2a, m into 2a minus ma by square root of 1 plus m square, this distance is given to be a. So, if you simplify that, you will have m is equal to 3 by 4. And the another one is a vertical line, which is a slope infinity. You will get the other line, you will get two signs, and with one sign, the slope m value is 3 by 4, and the other side, with the other sign, you will take m is equal to infinity. That means a vertical line. So, that is why it was one of the lines. So, the correct option is option number 3, 158. A 4 comma 2, B 2 comma 1, C minus 1 comma 1 are the midpoints of the sides PQ, QR and RP respectively of triangle PQR, then the area of triangle PQR. Of course, only the description of the problem is lengthy, but the solution is very simple. And all of you know by elementary geometry about the triangle, you know that the area of the triangle formed by the midpoints of the sides of a triangle is 1/4 of the original triangle. So, the original triangle area is 4 times the triangle formed by the midpoints. So, the area of the triangle formed by the midpoints is simply 3/2. So, the midpoint, the area of the triangle PQR is 4 into 3/2, which is equal to 6. So, option number 3, 15, next, 159. The area of the quadrilateral formed by the lines mod x minus 1 plus mod y minus 3 equal to 0 is equal to 1, is equal to 4, 2, 6, 3, 1, 4 is equal to all in square units. And here please you shift the origin to the point 1, 3. That means put capital X is equal to small x minus 1, capital Y is equal to small y minus 3. And all of you know that by changing the origin or shifting the origin or rotation, so the lengths and areas of figures, they will not change. Only coordinates will change. The length will be same and the area will be same. Okay. So, make it a point that by transformation, changing the axis or rotation of axis and shifting of origin, they never affect the measures of just like measures of lengths of segments and areas of the figures. So, here by shifting the origin to the point 1, 3, you will know that the equation becomes mod x plus mod y is equal to 1, and you know that those lines, 4 lines, mod x plus mod y is equal to 1, they represent 4 lines, namely x plus y equal to 1, minus x plus y is equal to 1, x minus y is equal to 1, and x plus y is equal to minus 1, and which form a rhombus but a square. It is a square whose area is 4 times the area of the triangle in the first quadrant. So, that area is simply 4 times area of the triangle in the first quadrant, and that is 4 into 1/2, which is equal to 2 square units. Here I have written also, change of axis will never affect the lengths and the areas. So, option number 2, correct answer is area 2. So, option number 4. Question number 160. ABC be a right angle triangle such that angle B is equal to 9 degrees, and further angle B is equal to vertex B is equal to 2, 1, and the equation of the hypotenuse AC is 2x plus y minus 3 equal to 0. Then the combined equation of the sides AB and BC. Suppose the equation of the side BC is y minus 1 is equal to m into x minus 2. Here one simple word is missed, that is that ABC be right angled isosceles, that must be there. Of course, you please insert that one, the students, I request that ABC be right angled isosceles triangle, such that if you see the figure, you can identify that the mistake. In the figure I have written angle BC is equal to 45 and angle BAC is equal to 45. So, that means right angled isosceles. So, angle BC is equal to angle BAC is equal to 45, slope of AC is minus 2. So, therefore, that 1 is equal to tan 45 is equal to modulus m plus 2 by 1 minus 2m. So, m plus 2 is equal to plus or minus 1 minus 2m. So, the slopes of m is equal to 3 or minus 1 by 3. Now, if you substitute in the equation y minus 1 is equal to m into x minus 2, the value is 3 and minus 1 by 3. And you will get the individual separate equations of the bisected of the sides. If you multiply them, those two, you will get the combined equation, and the combined equation of those two lines is nothing but given by option number 2, 161. Locus of a point which is equidistant from the lines x plus y minus 2 root 2 equal to 0 and x plus y minus root 2 equal to 0 is 1 x plus y minus 5 root 2 equal to 0 and 2 x plus y minus 3 root 2 equal to 0 and 3 2x plus 2y minus 3 root 2 equal to 0, and 4 2x plus 2y minus 5 root 2 equal to 0. Same model already we have discussed. So, only to emphasize, so on each model I have given more than one problem, because the student must sink the basic properties and ideas. So, now again the two given lines are parallel lines and the distance between them is 1 unit. So, the required line must be in between the midway between the two lines and parallel to the two lines. So, and among these, that means now the required lines midway between them, that is at a distance of half unit from both the lines, which is nothing but 2x plus 2y minus 3 root 2 equal to 0, or x plus y minus 3 by root 2 equal to 0. So, correct option is option number 3. 162. 4 lines, of course that these extra 4 lines are given by x plus 2y minus 3 equal to 0 and 3x plus 4y minus 7 equal to 0, 2x plus 3y minus 4 equal to 0 and 4x plus 5y minus 6 equal to 0. Then this is 1. All the 4 lines are concurrent, all the 4 concurrent. 2. They are the sides of a quadrilateral. 3. Only 3 lines are concurrent. And 4. 2 pairs of concurrent lines. And this is asked in JEE 1980. Now, if you consider this, of course, the problem is a very simple idea, concurrence, the checking, but you have to check. So, in those days, of course, the techniques are limited. So, what they have tried is, they have obtained the point of intersection every 2 lines and substituted those coordinates in the other 2 lines. If they satisfy other 2, that means the 4 lines are concurrent. If they satisfy, if that point satisfies only one and not the other, then only 3 lines are concurrent. So, like that, because so then you will get, you have to solve 4 equations taken 2 by 2. That means 4C2 combinations you will get. But here if you take the 3 lines and concurrence, use the concurrence, then you will get only, check only 3. So, the given lines will be, suppose the given lines are L1 equal to 0, L2 equal to 0, L3 equal to 0 and L4 equal to 0 in the given order. Now, L1 equal to 0, L3 equal to 0 and L4 equal to 0 are concurrent only when the determinant formed by their coefficients is equal to 0. Now, if you take the determinant formed by their coefficient 1, 2, minus 3, 2, 3, minus 4, 4, 5, minus 6 is equal to expanding, you get 2 minus 8 plus 6 equal to 0. That means the lines L1, L3 and L4 are concurrent. L4 are concurrent. Next, you consider the lines L1, L2, L3. That means 1, 2, 3, 3, 4, minus 5, 2, 3, minus 4, which is the determinant is not equal to 0. 21 minus 7, which is 14, not equal to 0. That means the lines L1, L2, L3 are not concurrent. And similarly, you can see that the lines L1 and L2 are not L1, L2, L4 not concurrent. That is now this is okay, because only 3. So, because these are not concurrent, so only the 3 lines, first L1, L2, L3 and L4 are concurrent, and remaining all the 4 lines are not concurrent. So, the correct option is 3. Only 3 lines are concurrent. And this problem I told you already, JEE 1980. The another way is find point of intersection of every pair and check whether that point lies on the other 2 lines or not. That is normal procedure. 163. The points minus A minus B, 0, 0, A, B and A square, AB are 1 collinear, wedges of a parallelogram, 3 wedges of a rectangle, 4 wedges of a rhombus. This is JEE 1979. Right. And you know that clearly B is the midpoint of AC, because see, A is minus A, minus B, C is A, B and B 0, 0. So, B is the midpoint of AC. So, therefore, ABC are collinear. ABC are collinear. And slope of AC is 2B by 2A, which is equal to by B by A, and slope of CD is also B by A, and A not equal to 1. So, ABCD, since A is not equal to 1, ABCD are collinear points, but when A is equal to 1, what happens? D and C will be same. When A is equal to 1, D and C will be same, and you know that ABC are collinear. We have seen that ABC are collinear. So, that is why in the verification, slope of CD, we have taken A is not equal to 1. One may ask, sir, why A is not equal to 1? If A is not equal to 1, both C and D are same point, and we checked that already ABC are collinear. So, in any case, when A is equal to 1 or A is not equal to 1, the points A, B, C, D are collinear. Correct option is option 1. Right. 164. The orthocenter of the triangle formed by the lines xy is equal to 0 and x plus y is equal to 1 is half comma half, 1 by 3 comma 1 by 3, 3 origin, and 4 1 by 4 comma 1 by 4. And this is asked in JEE 1995. Now, you know that xy equal to 0 means x and y axis. X is equal to 0 and y is equal to 0. So, that means the other two sides are x and y axis. Third side is x plus y is equal to 1. That means the triangle formed by them is a right angle triangle. Right angled at the origin. So, the orthocenter is right angled vertex, which is nothing but origin. So, therefore, the correct option is 3. Okay. Right. Next. If x1, x2, x3 as well as y1, y2, y3 are in GP with same common ratio, then the points A x1, y1, B x2, y2, C x3, y3, 1 are collinear, 2 lie on an ellipse, 3 are concyclic, and 4 form a triangle. So, JEE 1999. Now, you can suppose that x is equal to x2 is equal to rx1 and x3 is equal to rx1 square, and y2 is equal to ry1 and y3 is equal to ry1 square, because the common ratio is same. So, now slope of AB is y2 minus y1 by x2 minus x1, that is ry1 minus y1 by rx1 minus x1, that is y1 into r minus 1 by x1 into r minus 1, which is nothing but y1 by x1. And slope of BC, similarly y3 minus y2 by x3 minus x2, which is ry1 into r minus 1 by rx1 into r minus 1. So, which is nothing but y1 by x1. So, slope of AB is equal to slope of BC. So, therefore, the points ABC are collinear. So, you can remember that is a standard result. If x coordinates and y coordinates of 3 points, if x coordinates and y coordinates of 3 points are in GP with the same common ratio, then those 3 points are always collinear. And previously what we did is x coordinates are in AP and y coordinates are in also AP. There is no, the common difference need not be same. The common difference need not be same. Just x coordinates are AP, y coordinates are AP. Then also you have seen that those 3 points x1, y1, x2, y2, x3, y3 are collinear. So, I think this will be the last problem of this topic. Now, just we have a look at the entire topic. So, we have discussed many problems. In locus, of course, locus problem there is no end, because when the subject is developing, then you will get locus problems. You will get locus problems in circle and parabola, ellipse, hyperbola, and also in polar coordinates you will get. But the basic locus problems we discussed. And next, what we did is I explained the change of axis. The change of axis actually 3. One is shifting of the origin without changing the direction of the axis, and 2 that is rotating the axis without changing the origin. Next, shifting the origin and then rotating the axis, 3. Understand? So, in all these 3, we have discussed about the relation between the old and new coordinates. Understand? That is there. And some problems on C, and also we have discussed two aspects in change of axis. One is by using change of axis, we have discussed how to remove the xy term from the second degree equation and first degree terms from the second degree equation. That means, and all of you know that if one of a, h, b is not equal to 0, then the equation ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0 is called second degree general equation, and ax square plus 2hxy plus by square equal to 0 is called second degree homogeneous equation. Now, from the second degree equation, if you want to eliminate xy term from the equation, then what you do, you have to rotate rotate the axis through an angle given by half of 2h tan inverse 2h by a minus b when a is not equal to b, and if a is equal to b, automatically the angle of rotation will be 45 degrees. And to remove the coordinates, to remove the first degree terms of a second degree equation, you have to shift the origin to the point ℏ minus bg by ab minus h square, dh minus af by ab minus h square. And one more thing in that we did 2 or 3 problems. That means, suppose a second degree curve is nothing but represented by second degree equation. That means ax square plus 2x square plus by square plus 2gx plus 2fy plus c equal to 0. It always represents some curve called second degree curve. And if it is intersected by line Lx plus My is equal to 1 in suppose A and B points, in 2 points A and B, then the combined equation of the lines OA and OB we obtained by homogenizing the curve equation with the general equation of the homogeneous curve equation with the line Lx plus My is equal to 1. So, when you get to the combined equation of the lines OA and OB, and one more fact we observed is, if that OA and OB are at right angles, if and only if the coefficient of x square plus coefficient of y square equal to 0 in the transformed equation. Okay. So, by using that we have obtained we did some problems. So, those are the aspects with regard to the change of axis. Now, coming to the straight line, and we did problems, various problems using the various types of equations of a straight line. What are the types of equations of a straight line? The 2-point form, intercept form, general form, and normal form, and a condition for two straight lines to be parallel and perpendicular. And also we have discussed about the equation of the angle bisectors between two lines, and we covered all these concepts with the problems. So, that is why, so maximum we covered is, so 165 problems means it is more than enough for practice. So, with this we are concluding this topic. Thank you.